Have you ever just stared at a world map and had that weird feeling you're looking at a giant, jumbled puzzle? Well, that exact feeling kicked off one of the greatest geological detective stories ever told. Today, we're going to piece together the incredible mystery of Pangaea, the supercontinent that really started it all. You know what I'm talking about, right? It's something you notice in school, or maybe just randomly looking at a globe. It seems way too perfect to just be a coincidence. And it turns out that simple little observation is the very first clue in a puzzle that took scientists centuries to finally crack. And here's the most famous example of all. Just look at South America and Africa. The way those coastlines match up is, well, it's almost spooky. It's like they were once a single chunk of land that was just torn right down the middle. This one observation sparked a truly revolutionary idea. And that idea was, what if all those puzzle pieces were once part of one enormous picture? Scientists eventually gave this ancient giant landmass a name, Pangaea. So, what exactly was Pangaea? Okay, I want you to imagine all the land on Earth. North America, Asia, Europe, Australia, all of it, fused together into one colossal continent. That was our world 300 million years ago. A planet so different from ours, it might as well have been an alien world. Now, just think for a second what that really means. A world with one giant landmass also means one giant globe-spanning ocean. And, this is a big one, it meant that plants and animals could just walk across lands that are now separated by thousands of miles of water. Okay, so a giant supercontinent is a really cool theory, but science needs proof, right? How did we get from, hey, the coasts kind of look like they fit, to a full-blown accepted scientific theory? Well, it was like a massive detective case, and the clues were hidden all over the planet. So the investigation started by looking for evidence buried right under our feet, hidden away in the very crust of the Earth. And you know what? It turns out the evidence was absolutely overwhelming. Scientists pieced this incredible story together using three main types of clues: that obvious puzzle piece fit, some really surprising fossils, and massive geological formations that just shouldn't be where they are. This was a huge breakthrough. For instance, they found fossils of the exact same freshwater reptiles and land-based plants in both South America and Africa. Now, these little critters definitely could not swim across the Atlantic. So what's the only logical explanation? The continents themselves must have been connected. There's no other way. And the evidence just kept piling up. Geologists found that the Appalachian Mountains in North America, they're made of the same type and age of rock as mountains way over in Scotland and Scandinavia. It's like a single mountain range was literally ripped in half when the continents drifted apart. The scientist who dared to connect all these dots was a man named Alfred Wegener. All the way back in 1912, he proposed his radical theory of continental drift, arguing that continents weren't fixed in place, but were actually moving. But despite all his evidence, the scientific community just wasn't buying it, and for one huge reason. Wegener had the what, but he didn't have the how. He just couldn't come up with a force powerful enough to push entire continents around the globe. So for decades, his amazing theory was mostly ignored. But science, it just keeps pushing forward. Decades later, new technology let us map the ocean floor for the first time, and we finally found it, the engine that Wegener was missing. And the answer is something called plate tectonics. This is the grand, unifying theory of geology. It says that the Earth's crust isn't one solid piece. Nope, it's actually broken up into these massive slabs, kind of like a cracked eggshell. And these giant plates are constantly, slowly moving. So what makes these giant plates move? It's a process called mantle convection. The easiest way to picture it is to think of a giant, super slow motion lava lamp inside the Earth. Hot rock from deep inside rises up, cools off near the surface, and then sinks back down. This slow, powerful churning creates currents that literally drag the continents along for the ride. Now, we're not talking about a high-speed chase here. These plates drift at about the same speed your fingernails grow, just a few centimeters a year. But over millions and millions of years, oh yeah, those few centimeters add up. They add up to enough to rearrange the entire face of the planet. This timeline really puts that immense scale into perspective. For millions of years, Pangaea was whole. Then, around 200 million years ago, those convection currents started to pull it apart. The supercontinent began to fracture. And over the next 200 million years, that slow, relentless drift brought us to the world map we know today. So, we've solved the puzzle of the past, which is amazing. But why does any of this matter to us right now? Well, Because the story isn't over, not even close. The same forces that broke apart Pangaea are still at work, reshaping our world as we speak.
That's right. This isn't just something that happened a long time ago. It's happening right now. North America is still moving away from Europe. The Himalayan mountains are still being pushed higher. The ground beneath our feet is anything but static.
And this one theory is the key to understanding our planet's geology today. Plate tectonics doesn't just explain the past, it explains our present. It's the reason we have earthquakes. It's the reason we have volcanoes. It's why we have those majestic mountain ranges that define our world.
So, if there's one big thing to take away from all this, it's that we live on a dynamic, breathing planet. The world map we know and love is just a snapshot in time. The continents have been on an epic journey for billions of years, and that journey is far, far from over.
Which, of course, leaves us with one final, fascinating question to think about. Geologists are already making predictions, about new supercontinents forming in the far distant future. It's a powerful reminder that the story of our planet is still being written, 1 centimeter at a time.